All right, all right. I've never really gone down the road with the kinematic equations too in such detail before with this class, but I just felt like it was I don't know, like it was a good thing to do because you really haven't taken a physics class unless you've done them, and we're just doing them in the context of sport, and we're doing, and I'm not going to throw any curveballs at you like I would, the in the upper level physics courses at all, because that's not what you're here for. You're here to learn a little science, get a little appreciation for it, mix it up with some sports, and see some really cool sports things. And we've got a video coming up of the women's 100-meter dash at the Rio Olympics in 2016, and those young women are amazing athletes, and it's just I used to always use Usain Bolt, and it's like, well, why these young women are outstanding. But so here you all are used to this, right? That the distance something goes is equal to the rate times the time. Remember that? Distance equals rate times time. Well, and that's good. That'll get you through some, 8th, 7th, 8th, 9th grade science classes, and there's nothing wrong with it. The thing is, they're not including the acceleration, which changes. This will work as long as the rate is constant. Okay, this will always work as long as the rate is constant. All right. So, but we do it this way in physics. We say x is equal to the average velocity, because we're going to assume an average acceleration, the average velocity times the time. So this is distance. This is the average velocity times the time. Okay, we're going to get the average velocity of that young woman to see what her time, to get what her average velocity was, and maybe even to calculate her acceleration. All right, and so we also do this, and here's the other tricky one. X is equal to the initial velocity times the time plus 1/2 times the acceleration times the time squared. So if you're given the time and the acceleration, okay, you should be able to calculate the distance. All right, we don't do too many of those. I'm going to try and avoid those. I'm just going to keep it right here. And up here, I forgot one quick thing, that the average velocity is equal to v final plus v initial divided by 2. Now, one thing I can't do too much, we can look at the average speed of what we're going to do is we're going to find our average speed just based on what her average speed was, just based on the distance. We know the distance she went divided by the time. So that's all we'll do, because, and then some more detailed problems, we might look at these types of things. But I don't think so. I don't think we're going to go down that road. So let's watch. So keep these guys in mind, and let's watch this young lady, Elaine Thompson, win. Well, it's a 9-minute video, but it builds the tension. It's really well done, and it builds the tension. So let's go to that, shall we?